Why do American cars mostly use 0W-20 oil, while in Europe, Asia, and other regions, 5W-30 is standard? This isn't just a marketing gimmick or a random choice. It's the result of decades of engineering decisions, climate considerations, fuel economy mandates, and emission regulations. As a mechanic with 15 years of experience, I've seen how using the wrong viscosity in the wrong car quietly kills engines, reduces efficiency, and voids warranties. In this video, I'll break down the 10 reasons behind this difference, including temperature tolerances, engine design, emission controls, and oil chemistry. By understanding these reasons, you'll not only protect your engine, but also make smarter maintenance decisions and avoid unnecessary repairs. Hit subscribe to Care Xpert so you never fall for the one-oil-fits-all myth. Let's start with the first reason. It might surprise you why your U.S. car's manufacturer insists on 0W-20. Number 1. Engine design and tight tolerances. U.S. automakers design engines with tighter tolerances to improve efficiency and reduce emissions. 0W-20 is thinner, flows faster at startup, and lubricates these narrow clearances immediately. European and Asian engines often use slightly looser tolerances, allowing thicker oils like 5W-30 without impacting startup lubrication. The difference affects friction, heat management, and overall longevity. Using the wrong viscosity can cause premature wear or reduce efficiency. This is why manufacturers strictly specify oil grades. And that leads directly into the next reason, which involves climate control and cold starts. Number 2. Cold start performance. 0W-20 flows quicker in cold temperatures, protecting engines during winter startup. In the U.S., most regions experience cold mornings, and quicker oil circulation prevents metal-to-metal contact. Thicker oils like 5W-30 take longer to circulate in extreme cold, potentially increasing wear during the first minutes of operation. European and Asian countries often factor in milder winters or rely on block heaters in cold regions, allowing thicker oils without compromising engine protection. Cold start lubrication is critical, but it's only one of many reasons why viscosity standards differ globally. Number 3. Fuel economy standards. U.S. corporate average fuel economy, CAFE. Regulations push manufacturers to reduce friction and improve MPG. 0W-20's low viscosity reduces drag inside the engine, boosting efficiency. European cars prioritize a balance of fuel efficiency and durability, allowing 5W-30 without failing emissions or fuel economy tests. The choice of oil directly impacts rolling resistance and engine output. Using a thicker oil than recommended in the U.S. can actually lower fuel efficiency by a few percent, noticeable over time. Next, let's examine emission system compatibility. Number 4. Emission control systems. Modern engines rely on precise oil chemistry to protect catalytic converters and particulate filters. 0W-20's thin profile reduces oil consumption and keeps the emission system clean. Using thicker oil, especially in U.S. engines with tight tolerances, can increase deposits in the combustion chamber and exhaust, triggering check engine lights and even warranty issues. European and Asian engines are often designed with emission systems that tolerate slightly thicker oils. Proper oil choice is critical to ensure both compliance and long-term reliability. Now let's move to how oil shear and engine load affect viscosity choices. Number 5. Oil shear and high rev conditions. Engines in the U.S. are often tuned for lower RPMs and lighter loads, where 0W-20 maintains viscosity even under shear stress. In contrast, European cars may experience higher rev ranges or turbocharged engines designed to tolerate thicker 5W-30 oil. Thicker oil resists breakdown under heavy load, but flows slower at startup, making 0W-20 ideal for U.S. driving conditions. Choosing the wrong oil grade in either region can compromise both performance and longevity. But temperature range isn't just about cold starts. Heat tolerance is another major factor. Number 6. Operating temperature range. 0W-20 is formulated to perform in typical U.S. temperature ranges, providing fast flow at low temps and stable protection at moderate highs. 5W-30 offers slightly better protection under sustained high temperatures, which suits European summer driving conditions or heavy load engines. US engines aren't usually designed for constant extreme heat, making the thinner 0W-20 optimal. Using 5W-30 in a US engine may reduce efficiency, while 0W-20 in European engines could slightly increase wear under prolonged heat. Temperature adaptability is just one piece of the viscosity puzzle. The next reason involves oil certification standards. Number 7, API and ILSEC certification differences. 0W-20 oils used in U.S. cars meet strict API and ILSA-CGF standards for fuel economy, deposit control, and wear protection. European oils, often 5W-30, adhere to ACEA specifications that balance protection, oxidation resistance, and multi-fuel compatibility. Using an oil certified for the wrong standard can reduce performance or void warranties. Manufacturers design engines with the chemistry of their regional oil standards in mind. Oil certification isn't just marketing. It's a critical reason why viscosity differs across continents, and that ties into additive packages. Number 8, additive packages and engine protection. 0W-20 oils contain additives optimized for tight U.S. engines. Detergents, anti-wear agents, and friction modifiers are balanced for lower viscosity. European 5W-30 oils have slightly different formulations to handle higher loads or longer service intervals. Using the wrong oil can either cause excess friction or leave metal surfaces underprotected. Additive chemistry affects wear, deposit buildup, and longevity, making it a major reason regional oil choices vary. The next factor is related to oil change intervals. Number 9, oil change intervals. U.S. vehicles often have shorter oil change intervals due to lighter loads, tighter tolerances, and 0W-20's fast-flowing nature. European cars running 5W-30 are engineered for longer intervals under thicker oil. The oil's viscosity affects how quickly it breaks down under driving conditions. Using the wrong oil can reduce effective intervals, leaving engines vulnerable. Observing manufacturer specifications is critical, but driver behavior and fuel type also influence oil selection. Number 10, fuel type and combustion characteristics. U.S. gasoline tends to have different octane ratings and sulfur content compared to Europe or Asia. 0W-20 is formulated to complement American fuels, controlling combustion residues and maintaining optimal viscosity. Using thicker oil in a U.S. engine may leave deposits that reduce efficiency. Conversely, European fuels pair better with 5W-30 for emission compliance and durability. Fuel compatibility and engine design go hand in hand when selecting the correct viscosity. Next, let's consider altitude and climate effects. The difference between 0W-20 and 5W-30 isn't a random number. It's a carefully engineered decision based on climate, engine design, fuel type, emission standards, and component life. Using the wrong oil can reduce efficiency, increase wear, or even void warranties. Every reason we covered today affects performance, reliability, and long-term cost. If this video helped you understand why your car needs a specific oil grade, hit like, because most drivers still ignore the details and damage their engines without knowing it. Subscribe to Care Xpert, follow these guidelines, protect your engine, and always respect your manufacturer's recommendations. Your car will last longer, perform better, and avoid unnecessary repairs.